Hello everyone, in this video I will be solving Excel IAL Statistics 1 Jan 2023 paper WST 0101. So let's get started. The first question is based on histogram. As you can see, we have the diagram, we have the table. For part A, you need to complete the frequency table. So we need to find this missing values, as in frequencies for the last two bar. For each bar, you have the values given in the table. For the first three bar, it's completed. You need to find the missing values. Okay, so let me just start with completing the diagram. At the y-axis, it's not labeled. You can start with 5, 10, 15, or you can go for 1, 2, 3, 4, 5, 6, 7, 8. Since the area, the frequencies and the area are proportional to each other, so that's why the formula is actually F1 by F2, A1 by A2. You can select any random, any two random bar. I need the value for this one, as in 18 to 25, this bar. I can take help from either of these three because the information of the three is already given here. Suppose I will be taking help from the first bar. So this will be my first bar, and the one I'm trying to find the value, the frequency of, is my second bar. So F1 is the frequency of the first bar, F2 frequency of the second bar, A1 is the area of the first bar, A2 area of the second bar. So frequency of the first bar, as in 5 to 10, is given in this table, which is 10. F2 is the frequency of the bar I'm trying to find, so let's assume it to be X. A1 is the area of this first bar, so since it's a rectangle, it's just the length into breadth, so we have 5 over here and then 2, so 5 into 2. And area of this bar, 18 to 25, you have 7, and the height of this bar is 5, so 7 into 5. So solving this, you will get the value of X, which is 35. So we will repeat the same process. So now I know the frequency of this bar. So I need to find the frequency of this last bar. I will take help from the first one. So next, this is my first bar, this is my second bar. So I will be using the same formula. So this time F1 by F2, A1 by A2. So frequency of the first bar is 10. Frequency of the second bar is unknown. Let's assume it to be Y. Area of the first bar, 5 into 2. Area of the second bar, this one. So 25 to 40, we have 15, and height of this bar is actually 1. So 15 into 1. So solving this will give you the value for Y, which is the frequency of the last bar. That's 15. So I'm done with part A. The table is completed. In total, you have 100 people. So if you add all this frequency, you will get 100. So you can cross-check whether your answers are correct or not, because the sum must be 100. Next, for part B, we need the number of people who took less than 16 minutes to swim. Suppose if I say that we need the number of people who took less than 10 minutes, it means we are talking about this bar, right? Less than 10. So we need less than 16. So 16 is somewhere over here. It's the midpoint of 14 and 18, right? So less than 16 means you are talking about this portion of this table. So I will just add the frequencies of this part, 10 plus 16, plus for this portion, 24 is for a gap of 14 to 18, right? but we need up to 16, as in 14 to 16. Since 16 is the midpoint of 14 and 18, that's why you can just directly divide 24 and divide it by 2, as in half of this here and then the remaining one at the right side. So 12, 12. This is easy because it's the midpoint. Otherwise, we would have to use the unitary method to calculate that value. So I will just take 24 by 2 because I need up to 16. So for part B, number of people is actually 10 plus 16 plus 24 by 2. So the answer is 38. Next, for part C, you need to calculate the mean. This table is actually the group data, right? The values are given in range. So mean is actually, you need to multiply this, but we need to select the midpoint of this, right? So 5 plus 10 divided by 2, midpoint into 10, as in I'm calculating the sum. I'm calculating the sum, which is basically weight. If you want to write the formula, it should look like this. Sum of f into t, frequency into time, divided by sum of f, which is the total frequency. The total frequency, you can add this or you can select 100 directly. So for sum, you need to multiply this. The midpoint of this is 7.5 into 10. So I'm just including the complete step. So 5 plus 10 divided by 2 will give me the midpoint of this into frequency 10 plus midpoint of this, which is 12. You can directly use 12. I'm just including the complete step. So into 16. Then 14 plus 18 divided by 2 into 24. Next, 18 plus 25 by 2 into 35. The last one is 25 plus 40 by 2 into 15. So from the calculator, you will get 1891 at the numerator. The final result is 18.91. Okay, next you need the standard deviation. So the formula for the standard deviation is this: f of t square by sum of f minus sum of f of t divided by sum of f whole square. That's the formula for variance. When you take the root over, you get the standard deviation. So I will just substitute the values. F of t square is given. So 41033. Sum of frequency is 100. Sum of ft is what we calculated here at the numerator, which is sum of ft 1891 divided by 100 whole square. So from the calculator, you will get the result, which is 7.262. So part A, B, C, D done. The last one, you need to calculate. Q3 is given. You need the interquartile range. Interquartile range is basically Q3 minus Q1. Q3 is already given, so it means we need to calculate Q1 first. So Q1 is the lower quartile. For Q1, you need n by 4. That's the position of Q1. So n by 4, n is 100, as in the total frequency, sum of all the frequencies, divided by 4, that's 25. So the formula to calculate Q1 is this: L plus n by 4 minus capital F by small f into CW. So L is the So this 25 means 25th position. So the first group has 10 data, the second group has 16 data. So if you add this, you get 26. So up to the second group, the first group has 10 data. Starting from the 11th up to 26th, all the data are within the second group. So I need the 25th one, right? So which is obviously within the second group. So this is the group where the Q1 lies. So you need to pick the group first, and from here L represents the lower limit of the group, lower boundary, which is 10. Since there's no gap, so I do not need to modify anything. I can directly pick 10. But if it the value ended at 9 and it starts at 10, if there is a gap of 9, gap of 1, in that case the value of L would have been 9.5. But this problem is a little bit easier because we do not have any gap. We can directly pick the value of L as 10. N by 4 is 25. Small f is the frequency of this group, 16. Capital F is the cumulative frequency up to the previous group. So since we have only one group, we will directly pick 10. If you had multiple groups, in that case you have to add the values and take the cumulative frequency. CW is the class width, as in difference between this upper and lower boundaries, 14 minus 10. So calculating this will give us a value of Q1, which will be 13.75. So we had to calculate the interquartile range, right? So I will just substitute Q3 is 23 and Q1 is 13.75. So the final result is 9.25. So I'm done solving number 1. Next is number 2. Number 2 is from probability, and we have a tree diagram here. We have two bags, X and Y, each contain green marbles and blue marbles. Bag X contain, so we have two bags. Just let me just draw them. Suppose this is bag X, the next one is bag Y. The first bag has 5 green marbles and 4 blue marbles. The second bag Y contains 6 green marbles and 5 blue marbles. So this one has 6 green marble, 5 blue marble. This one has 5 green marble, 4 blue marble. So in total you have 9 marbles in bag X, and in total you have 11 marbles in bag Y. A marble is selected at random from bag X and placed in bag Y. Okay, so you are selecting one marble from X and you just place it in the second bag. A second marble is selected from X and placed in bag Y, so you will repeat the process. You will take another one from X and put it in the bag Y. A third marble is selected from bag Y. So the first marble, second marble, then the third marble will be selected from this bag Y. So this is the scenario. So let's start solving the question. For part A, you need to complete the tree diagram. So we need to complete this tree diagram. The first marble will be selected from bag X. It could be a green or a blue. Number of green is 5, total is 9, so that's why 5 by 9. So a few values are already filled up. We need to complete the diagram. So let's start. So if the first marble from the bag is blue, and then if the second marble is blue, you are trying to fill up this one. So you had 4 marbles in the bag. So if you have selected marble blue marble, in that case number of blue will decrease, so 4 will become 3. Total number of marble will also decrease, so 9 will become 8. As in, you are selecting, the first one is blue, the second one is blue. Initially you had 4 blue marbles, so 4 by total, and then the second one will be 3 by 8, so that's the 3 by 8 part. And since the total value of any branch is 1, so I can calculate the other portion. 1 minus 3 by 8 will give us a value which is 5 by 8. So the last portion is the third bag, right? So let's consider this one first. If the first 2 marble are green, if you select one green, if the 2 marbles picked from bag X are green, in that case bag Y will have 8 green marbles now, right? Initially it had 6 marbles, but since you are transferring 2 green marbles, now you have 8 green marbles. And since you are actually placing 2 extra marble, total number of marble in bag Y is now 13. So total number is always 13. And for this branch, if we are considering 2 green marbles are added here, so instead of 6 we have 8 green marbles, and total is 13. We can find this value by subtracting this. 1 minus 8 by 13 will give you this value, which is 5 by 13. Okay, so let's consider second scenario. You need to understand that whatever the color is, total number of the marble in bag Y is actually 13, because you have transferred 2 marbles. So all this will have 13 at the denominator. So let's consider the second situation. If the first marble selected is green, the second one is blue, in that case you will have 1 extra green, 1 extra blue, right? So the green is 7, blue is 6. So in short, if the first marble selected is green, as in 1 green and 1 blue, you have transferred 1 green and 1 blue. So what is the probability of green? So you have picked one, placed 1 green here, so the total number of green is now 7 by 13. We do not even need to analyze the other part for B. You can just deduct this value from 1, so this will be 6 by 13. And if you want to analyze the situation, since you have transferred 1 blue, blue is 6 now, so 6 by 13. I think it's easier if you consider just one color. Okay, next one. This is a similar case, 1 blue and 1 green. So what is the probability that you will be picking a green from bag Y? Since you have placed 1 green and 1 blue, green has increased from 6 to 7, just like the previous case. So 7 by 13, and this is 6 by 13. So tree diagram is done. This is part A. For part B, we need to find the probability 2 marbles selected from bag X are of different color. So bag X means you need to consider this part of the diagram only. You can skip the last part. But if you needed something from this third branch, third part, you had to start from the very beginning, and you need to select first, second, and third. But since I need up to bag X, I will just consider this portion of the curve of the diagram. So different color from bag X. So different color from bag X. So it could be green, blue, probability of green, blue, or the other sequence, blue, green. The first one is blue, the second one is green. So for each branch, you just need to multiply the values. 5 by 9, 4 by 8. And for the second branch, it's 4 by 9 into 5 by 8. So the answer is 5 by 9. Next, all 3 marbles selected are of same color. So all are same color. So either it's green, green, green as in the first branch, or blue, blue, blue. So probability of green, green and green, blue, blue and blue. So for the first branch, you need to multiply these 3 values. 5 by 9, 4 by 8, 8 by 13. Then for the blue, 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 it's 4 by 9, 3 by 8 and 7 by 13. 4 by 9, 3 by 8, 7 by 13. The answer is 61 by 234. Given that all 3 marbles are of the same color, as in the situation we just used in part C, this is the given that situation. Whenever you have the given that situation, remember that this is your new total. This is the part where you need to select the values from. You cannot get out of this situation. You need to use that given that situation at the denominator. This is your new total, so you need to divide that. So given that the 3 marbles are of the same color, so we have already calculated that probability for part C. So this is my denominator because this is the new total. So I will be able to select from these 2 branches only, green, 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 blue, 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 because given that situation is that the colors are same. All these 3 are of same color, so you cannot pick any other branches. You need to select only from these 2 branches. These 2 branches are my new total, so that's why I have divided this thing by the answer to part C. And from this 2, I need to select the probability that they are all green, as in green, 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 the first branch. Probability of green, 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 the first branch, this one. Number 3 is from Discrete Random Variable chapter. We have the probability distribution table. For part A, you need to calculate E of x. E of x is the expectation, as in the mean, the average. For that, you just need to multiply this and add this. So E of x is 2 into alpha, 2 into A. Next, 3 into 0.4 and 4 into 0.6 minus A. Next, for part B, we need to find the range of possible values of E of x. If we just look at the table, the probability are in terms of A, and you need to understand that probability is always positive, so this has to be greater than 0, this has to be greater than 0. So from here you get an idea that A is greater than 0, and if we simplify this one, so first thing is A is greater than 0, and from the second part, 0.6 minus A greater than 0, if we simplify this, when you shift the negative sign at the right side, the inequality sign will be reversed, so it's less than 0.6. So A is greater than 0 but less than 0.6. So if I combine this one, the final result is like this, from 0.6 to 0.6. This is the range of A. but we need to find the range of possible values of e of x. Since e of x is already, we have already calculated that in part A, but it's in terms of A, we will just use the value of A to get the upper and lower value of e of x. So when A is 0, e of x is 3.6 minus 0, which is 3.6. Next, when A is 0.6, e of x is 3.6 minus 2 into 0.6, which is 2.4. So the final limit of e of x is like this: greater than 2.4 but less than 0.6. Next, for part C, the variance is given. The variance is given. You need to find the value of A. So we will just substitute variance of x, e of x square, e of x whole square, everything, and solving that will give us the value of alpha. So let's start. At first, we will try to find e of x square. E of x square means x square into probability. X square into probability, as in 2 square into alpha, 3 square into alpha. So 2 square into alpha, 3 square into 0.4, 4 square into 0.6. Simplifying this will give us something like this: 4a, 3.6, 9.6 minus 1 minus 16. 4 square is 16, right? (13.2) minus 12a. So e of x square is 13.2 minus 12a, and e of x whole square. E of x whole square. E of x is this one: 3.6 minus 2a whole square. So I just need to simplify this line. This will be expanded using a minus b whole square formula, as in a square minus 2ab plus b square. So this one will be 12.96 minus 14.4a plus 4a square. So the signs are reversed because of the minus in front of the bracket. 1.2 minus 12.96 is 0.24 plus 2.4a minus 4a square, and the value of the variance is given 0.56. 0.56. So if I shift everything at the left side, it's actually 4a square minus 2.4a, then plus 0.32. So you can actually convert this into integer form and then use middle term equation. Solve this using middle term concept, but since it's in terms of decimal format, I will just use the formula: minus b plus minus root over b square minus 4ac by 2a, where a, b, c, a is 4, b is minus 2.4, c is 0.32. So when you simplify this, you will get two different values. A is 1 by 5 and a is 2 by 5. Number 4 is basically from the chapter probability, but the concept is based on the Venn diagram. The most important thing you need to know is about the set notation and the shading part. So I will be adding the link in the description below to actually help you with the concept of shading. So in this one, you have set A, set B, all the values are in terms of alphabets. It's the values are unknown, and we need to actually show this one. So let me just use the given information. So from the first information, probability of A, it means the circle A, total probability of A is 7 by 25. So it means P plus Q. If I just take this portion, P plus Q is 7 by 25. This is my equation 1. Next, B is 1 by 5. So the circle B, complete circle B, is 1 by 5. So Q plus R is 1 by 5. This is equation number 2. Next, the third one, A intersection B prime. A intersection B prime means you cannot include B. You have to exclude B. So outside the circle B, we need to select something which is common with the A, because intersection means you need to pick something which is common with A. So you have excluded B. Apart from B, we are left with these two values, and from this two value, A is here. P is included in A. So value of A intersection B prime is actually P. Next, A intersection B prime. A prime intersection B. A prime means you need to exclude A. So A is excluded. From the remaining one, you need to select something which is common with the B, because we have an intersection here. So R is within B. So value of A prime intersection B is basically R. And this bracket, as in P and R, in between two you have a union, as in you need to select both P and R. So P plus R is equals 8 by 25. That's the third equation. For part A, you need to show 2P plus 2Q plus 2R. So it's just that if I actually add these three equations, you have 2P, 2Q, 2P, 2Q and 2R. So adding this three equation will give us the required expression. So I will be adding these three equations. So P plus Q, Q plus R, P plus R. I will be adding this three. And at the right side, you will just add the three values. So at the left side, you have 2P, 2Q and 2R. And at the right side, you get 4 by 5. So that's it. This is part A. Next, you need to find the value of QRS, PQRS. You need to calculate all the values. We have 4 unknown terms. So far you have only 3 equations, but in total for 4 unknowns you need 4 equations, right? So the last equation, you can actually use the concept that total probability is actually 1. So if I add all these values here, P plus Q plus R plus S equals to 1. So this is the fourth equation. So I will just solve these 4 equations to get the values of P, Q, R, S. So first of all, I can actually replace P, Q, R from this expression, as in from part A, if you just factorize it a little bit, P plus Q plus R is 4 by 5. So from there, you know the value of P, Q, R, which is 4 by 5 divided by 2, as in 2 by 5. So I know the value of P, Q, R, which is 2 by 5. So I will be replacing P, Q, R here. So I will be replacing P, Q, R in this equation. So 2 by 5 plus S equals to 1. So solving this, you will get the value of S, which is 3 by 5. Next, I will use this fourth equation, P plus Q plus R plus S equals to 1. So I can replace P plus Q from equation 1. P plus Q is 7 by 25. So 7 by 25 plus R plus S. S is 3 by 5. So solving this will give us the value of R, which is 3 by 25. Next, P plus Q plus R plus S equals to 1. So this time I will be replacing this part from equation 2. Q plus R is 1 by 5. So P plus 1 by 5 plus S. S is 3 by 5. So this is P 1 by 5. Last one. So now that I know all the values, I will just substitute them. P is 1 by 5. Q is unknown. R is 3 by 25. S is 3 by 5. So we are left with Q only. So Q is 2 by 25. So that's part B. Next, for number 2. We know the probability of C, probability of D. Considering P and P plus P, probability of P plus probability of D, we need to show that C and D cannot be mutually exclusive. So let me just calculate probability of C, probability of D. I'm substituting these values. If I take the LCM, you get x plus 5 into x. So at the numerator, you get x square, 5x plus 5. If I simplify it, x square plus 5x plus 25. At the denominator, it's x square plus 5x. As you can see that we can cancel this out. So let me just separate them. So x square plus 5x divided by x square plus 5x plus 25 by x square plus 5x, as in I have separated them so that I can cancel it out. It's actually 1 plus something. So the main idea is that from this line we can clearly see this value is actually greater than 1, right? 1 plus extra values. So this is actually greater than 1, indicating that C and D cannot be mutually exclusive, because if C and D are mutually exclusive, assuming that we do not have anything outside the circle, sum of C and D should be 1, right? But since we got 1 plus something, it means they are not separated, they are overlapped. Because when the two sets are overlapped, when you add probability of C, when you add probability of D, this portion is repeated. You are adding this portion twice, the total is exceeded and the value is greater than 1. So since probability of C plus probability of D is greater than 1, indicating that we do have a value in this overlapping portion, as in C intersection D must be greater than 0. There is a value in between the overlapping part, which is actually making the total greater than 1. So these two are not mutually exclusive. Number 5 is from normal distribution. The basic concept of normal distribution is already explained in a separate video. I will be adding the link in the description box. For part A, we need to find the probability that the length is less than 3.86. So 5A, probability length less than 3.86. So we know that whatever the letter is, whatever the situation is, we need to convert that into the standard variable z, and the formula is z equals x minus mu by sigma, right? Mu is this one, and this one is actually sigma square, indicating that sigma is 0.4. So mu is 4.5 and sigma is 0.4. So 3.86 minus mu by sigma, so minus 4.5 divided by 0.4. Z less than minus 1.6. So if we have z less than plus 1.6, it means we will just look at the table. For each values of z, you have a corresponding probability values, right? So this is the table. So we will just find out z equals to 1.6. The table is applicable for less than positive values of z, so 1.6. So the answer is 0.9452. 0.9452. 0.9452. But since we have to deal with negative value, for negative value you need to deduct this, the table value, you need to deduct that table value from 1, from total probability. The reason why we are actually deducting this, I have already explained the derivation in this separate video. It's actually related to the normal distribution diagram, so I'm not explaining that here. The main idea is that if you have a positive value, you can pick value from the table. If you have a negative value, you need to just deduct that value from 1. That's it. 0.0548. Part B1, we need to find the upper quartile Q3 and lower quartile Q1. So we know that Q1, Q2, Q3. So Q1 represents the 25th position, right? Q2 represents the 50th position, Q3 represents the 75th position. So probability less than Q1 is 25, probability less than Q3 is actually 75. That's the information we will be using for part B. So let's start B1. We need the upper quartile, which is Q3. So L less than Q3, probability is 75%, so 0.75. So I will just convert that into Z. So Q3 minus mean is 0, just like this. So 4.5 by 0.4. So in this case, 0.75 is the value of the probability. So we will try to find that value in the probability column, and we will just pick the value of Z. So 0.75 in the probability column, 0.75. 0.75 actually means 0.7500, because all these values are given to 4 decimal place. So 0.7500 is not available here, but if you just look at these two values, 0.7500, so this value is closer, right? We have a difference of, if we just look at this 500 and 486, we have a difference of 14 here. But if you look at this too, 517, we have a difference of 17. Since this is closer, I will just select this value, 0.67. You can even use unitary method to get an exact correct result. For the time being, I'm just using the closer one, which is 0.67. So this is the value of Z and this is the value of Z. So I will just equate that. So to equate that, you need a less than sign, obviously. The table is applicable for less than sign. So we will try to have less than sign always here. So solving this will give us the value of Q3. So this is actually 4.768. We will repeat the same process for Q1, the lower quartile. So less than Q1 means 0.25. If you need, then we will just convert this into Z. So right now there is a problem. The problem is that this 0.25 is not available in this table, because the table actually starts from 0.5. So whenever you have a value which is not available at the, in the table, you just need to select the alternate value. So let me just show you a shortcut here. The main idea is that total probability is 1. So if you have 0.5, the alternate value is 1 minus 0.25, which is 0.75. So if this is not available, the other one must be available. Always you select the other one, as in 0.5 is the mean, the middle value. So if it's greater than 0.5, then that's completely fine. You will get the value from the table, because the table starts from 0.5. All these values, if you look at the values of probability, these are greater than 0.5. But sometimes in this situation, when you have a value less than 0.5, you need to select the alternate one, 0.75, as in 1 minus this value. But you cannot just select randomly, right? If you want to write 0.75 at the right side of the equation, you need to change something at the left side. So the easy option is you just change this one, greater than sign. But the thing is, we have values for less than sign. The table is applicable for less than sign only, right? As you can see, the values given are for less than sign. So we always prefer having less than sign. So what can we do? We will change the sign of this. So the main idea is, you can either change the inequality sign, you can either change the sign of this part if you need to take alternate values at the right side. So in this scenario, I will just change the sign of this part. So I will just take the negative value. So it will be minus Q1 plus 4.5, as in 4.5 minus Q1 divided by 0.4. So this is the shortcut. Next, you need to find the outliers. This is the upper limit, this is the lower limit. If the values are within the limit, then it's not an outlier. But if the value goes out of the range, in that case, that value will be considered as an outlier. So we need to find those limits. We will just substitute the values of Q1, Q3. Okay, so this one is actually 4.768. We just calculated the value of Q3 and Q1 in part B. I'm using that value. So 1.5, 4.768 minus 4.232. So this is 5.572. That's the upper limit. And for the lower one, you substitute the values of Q1. Q1 is 4.232 minus 1.4 minus I can just use this value directly. So this will be 3.428. So that's part C. If the value lies within this range, as in greater than 3.428 but less than 5.572, then it's not an outlier, right? The range is this one. The value must lie within this range, otherwise it will be considered as an outlier. So for part D, show that the probability this housefly is not an outlier. It will not be an outlier only if it lies within this range, right? So probability, the length lies within this range, 3.428, 5.572. So next I will just convert them into Z. minus the mean 4.5 by standard deviation 0.4. So this is actually probability of z less than 2.68 minus probability of z less than minus 2.68, as in we need to take the values in between, right? So upper minus lower, that's it. So this value is you can pick that value from the table. For z 2.68, we will just pick the value of the probability 2.68. 2.68 is not available here. 2.68, so 2.65 is this one, so you have a difference of 3. 65, 68, but this one is 70, so you have a difference of 2, so it's closer to 2.7. So I will be using this one, 0.9965. 0.9965, and like I have already mentioned, for -1 you just need to deduct that value. You cannot directly pick the value from the table. You need to deduct that value, 0.9965. So this will be 0.993. That's part D. For part E, given that the housefly is not an outlier, it means this is my new total. Like I said, given that situation is your new total, you need to divide that that value. You need to divide the probability using by that value. So this, given that situation is your new total, that should be at the denominator level. Okay, and at the numerator, the wing length of this housefly is greater than 5. So the thing is, part E, the question is that it's a given that situation that this is not an outlier. It means the length must lie within the limit, right? So this is the given that situation, the value must lie within the limit, that's why it's not an outlier. So this is the given that situation, and probability of this you already know, 0.993, whatever. So this is the range, the length is within this range. Given that the length is within this range, we need to find the probability that length is greater than 5. So you cannot just write length greater than 5 at the numerator level, because it cannot be only greater than 5. You have an upper limit. It has to be within this limit. It means it has to be greater than 5, but it cannot exceed this value, right? You need to consider the given that situation. So it must be greater than 5, obviously, according to the question. It must be greater than 5, but it must also be less than this upper limit. So 5.572. So we know the value of the denominator, but the numerator we have to calculate that value. So let me just solve that part here. Probability length greater than 5, less than 5.572. So at first I will just convert that into Z. So 1.25. 13.93. 9.93. Sorry. .68. So this is basically z less than 2.68 minus z less than 1.25, right? Upper limit minus lower limit. So you will just pick values from the table. So when z is 2.68, z is 2.68, is closer to 2.7, so it's 0.9965, 0.9965, and 1.25. Z 1.25 is actually 0.8944. So 0.1021. So we will just, so that's the part E. So after this portion you will just substitute it here, 0.1021. So the result is 0.103. Last one, number 6. We have the regression line equation where x represents the temperature and y is the amount of sugar. Okay, so for part A, given interpretation of the gradient of the regression line. So in this equation, 151.2 is the amount of sugar that will dissolve even if you do not increase the temperature. But if you keep on increasing the temperature, obviously y will also increase. So if x equals to 1, with 151, you need to add 2.72 into 1. If x equals to 2, it will be 2.72 into 2. If x equals to 3, this will be 2.72 into 3. As in 2.72 is the gradient of the line, as in the amount of sugar will increase by this value. For each 1 degree increase of temperature, the amount will increase by 2.72. So the answer for part A is for 1 degree Celsius increase in temperature, extra 2.72 gram of sugar will dissolve. For part B, we need to find the maximum amount of sugar, as in y, that will dissolve when the temperature is 90. It means x is 90. What is the value of y? So that's 396. Part C, comment on the reliability. Give a reason. First of all, you need to cross check the range. Range was within 10 to 80, but x 90 is outside the range, right? Value is unreliable. Reason is that 90 degrees Celsius is outside the range. Next, for part D, we already have the values of this. We need to calculate the product moment correlation coefficient, which is the R. So R is sum of xy by root over sum of xx sum of yy, right? So for that we need to calculate these three values first. So let me start part D. I will just substitute these values into this formula. So for sum of x, you need to find sum of x square. So sum of x square is given 24500, but sum of x is not given. So we need to find sum of x, and for that we will be using the equation, main equation y equals 151.2 plus 2.72x. So in this equation, if we actually think about the mean of y and mean of x, mean of y means sum of y divided by n, right? Similarly, mean of x means sum of x divided by n. So we know the value of sum of y, which was given in the question. 3119 by n is given 12. So 151.2 plus 2.72 sum of x by 12. So from this equation we will get the value of sum of x. So let me calculate that. Wait. So we will just substitute the value of sum of x in this formula now. So this is the extra working we had to do so that we can get the value of x, sum of x. So minus 479.63 whole square divided by 12. 5329.4. For sum of sum of y square is given 851093 minus sum of y 3119 square by 12. So this will give us 4041.2.92. For sum of xy, this is the formula we usually use, but right now we do not have the value of sum of xy, so that's why you cannot use this one. So the gradient here is 2.72, right? So the sum of xy will be 2.72 times of the sum of xx. So 2.72 into 53294. So this will be 14495.97. Next we need the value of r, so we will just substitute the values here. 14495.97 by 5329.4, 4041.92. So this will give us a value of 0.98. For the last part, with reference, the research student supervisor plotted the original data on a scatter diagram with reference to the scatter diagram and the correlation coefficient. Correlation coefficient is R, which is 0.988. We need to discuss the suitability of a regression line model to describe the relationship between x and y. So if since R is almost close to 1 means it supports the linear regression model. But we need to also analyze the scatter diagram. So this is the scatter diagram. As you can see, the diagram also supports the same thing, that it's showing a pattern that it's going up, and the points are closer to a straight line. So the points are closer to each other, and they follow a pattern of a straight line. Then it also shows a positive correlation. Between x and y, which is also supported by the value of r. R is close to 1. So all of this thing actually indicate that a linear model is suitable. That's the end of S1 Jan 2023 paper. I will be adding the link of all the related videos in the description box. See you in the next video. Till then, take care. Bye bye.